A dim red sun casts a mysterious, muted glow across an alien horizon. Beneath it lies a world, slightly larger than Earth, locked in an eternal dance with its star. Welcome to Proxima b, the closest exoplanet to Earth and a tantalizing prospect in humanity's search for extraterrestrial life. In today's video, we're diving deep into Proxima b, a planet that could redefine everything we know about habitable worlds. From its unique orbit around the faint red dwarf Proxima Centauri to the challenges of its harsh environment, Proxima b offers both hope and intrigue. Join us as we explore its fascinating characteristics, the science behind its discovery, and what it might mean for humanity's future among the stars. Proxima b resides in the Alpha Centauri star system, the closest stellar system to our own, just 4.24 light-years away. At the heart of this system lies Proxima Centauri, a red dwarf star, much smaller and cooler than our Sun. Proxima b orbits this star at a distance of only 7.5 million kilometers, 20 times closer than Earth orbits the Sun. Despite this proximity, the planet sits comfortably within Proxima Centauri's habitable zone. The habitable zone is the region around a star where conditions might allow liquid water to exist, a key ingredient for life as we know it. But Proxima b's environment isn't just about distance, it's shaped by the unique properties of its parent star. Red dwarfs like Proxima Centauri are known for their longevity, often burning for trillions of years. However, they're also notorious for their activity, producing powerful flares and high levels of radiation. Proxima b, locked in a close orbit, is constantly exposed to these intense stellar phenomena. Proxima b was discovered in 2016 by astronomers using the radial velocity method. This technique detects tiny wobbles in a star caused by the gravitational pull of an orbiting planet. The data revealed a rocky world with a minimum mass of 1.17 times that of Earth, making it an Earth-like exoplanet in size. The planet's year is incredibly short, just 11.2 Earth days. This rapid orbit is due to its close proximity to Proxima Centauri. While scientists couldn't directly see Proxima b, the wobble of its star told an intricate story about its presence. What's more fascinating is that this discovery was only the beginning of unraveling Proxima b's mysteries. Follow-up studies focused on the planet's atmosphere, surface conditions, and potential for habitability. In 2020, researchers suggested the presence of a second planet, Proxima c, further expanding interest in this stellar neighborhood. But today, Proxima b remains the crown jewel of the system, a world that could hold the key to extraterrestrial life. Proxima b's extreme environment challenges our understanding of what makes a planet habitable. For starters, Proxima Centauri emits much less light and heat than our Sun, meaning Proxima b likely receives only about 65% of the sunlight Earth gets. This lower light level gives the planet a perpetual twilight, bathing its surface in a dim, reddish glow. Proxima b is also tidally locked, meaning one side of the planet always faces its star, while the other remains in constant darkness. The day side could experience scorching temperatures, while the night side might be frozen. Between these extremes lies a terminator zone, where temperatures might be more stable and suitable for life. Another challenge is Proxima Centauri's frequent stellar flares, which bombard the planet with ultraviolet and X-ray radiation. If Proxima b has an atmosphere, these flares could strip it away over time, leaving the surface exposed to the harsh vacuum of space. However, scientists speculate that a strong magnetic field could shield the planet, preserving its atmosphere and making it more Earth-like. Could life exist on Proxima b? This is the million-dollar question. Life as we know it requires liquid water, a stable atmosphere, and a source of energy. Proxima b checks some of these boxes, but the conditions are far from ideal. If the planet has a dense atmosphere, it could distribute heat across its surface, making it more habitable. The terminator zone, where light and darkness meet, could provide a stable environment for life to thrive. But without direct observations, we can only speculate about the planet's surface conditions. One possibility is that Proxima b has subsurface oceans, hidden beneath a thick layer of ice. Similar to Jupiter's moon Europa, these oceans could harbor microbial life, shielded from radiation by the ice above. Alternatively, if Proxima b has volcanic activity, it could provide the heat and nutrients necessary for life in subterranean environments. The Alpha Centauri system, consisting of Proxima Centauri, Alpha Centauri A, and Alpha Centauri B, has long been a target of fascination for astronomers. Unlike its larger siblings, Proxima Centauri is a red dwarf, a class of stars known for their cool temperatures and smaller sizes. Red dwarfs make up the majority of stars in the Milky Way galaxy, meaning planets like Proxima b could be incredibly common. Proxima b's close orbit suggests that it's deeply influenced by the gravitational pull of its parent star. Despite its proximity, Proxima Centauri's faint light means the planet remains relatively cool, compared to planets orbiting Sun-like stars. The concept of a habitable zone is more complex around red dwarfs, as their faint light and active flaring create unique challenges for planetary habitability. This cosmic neighborhood's proximity to Earth makes it a prime target for future interstellar missions. If we ever develop the technology for near light-speed travel, Proxima Centauri would likely be humanity's first destination beyond the solar system. The radial velocity method used to discover Proxima b is a cornerstone of modern exoplanet science. By measuring the subtle shifts in Proxima Centauri's spectral lines, astronomers detected the gravitational tug exerted by an orbiting planet. These shifts are incredibly small, akin to measuring the movement of a parked car's antenna from miles away. The confirmation of Proxima b's existence marked a milestone in the search for Earth-like exoplanets. It demonstrated that small, rocky planets could form around red dwarfs, a discovery that expanded the scope of habitable zone research. However, the precise conditions on Proxima b remain a mystery, fueling intense debate within the scientific community. To date, no direct images of Proxima b exist, its characteristics are inferred entirely from indirect observations. Advances in telescopes and detection methods are bringing us closer to obtaining a clearer picture of this intriguing world. Future instruments, such as the Extremely Large Telescope, ELT, promise to reveal Proxima b's atmosphere, surface composition, and even weather patterns. Proxima b's tidal locking poses both challenges and opportunities for habitability. The perpetual day side could host thriving ecosystems, provided it's not scorched by radiation. Meanwhile, the frozen night side could store vast reserves of water in the form of ice. The Terminator Zone, where day meets night, might be the most Earth-like region on Proxima b. Here, temperatures could remain stable, and the interplay of light and darkness might create unique ecological niches. If life exists, it might adapt to these extreme conditions, potentially evolving into forms unlike anything on Earth. Stellar flares from Proxima Centauri add another layer of complexity. These flares could strip the planet's atmosphere over time, unless Proxima b has a strong magnetic field. If such a field exists, it would indicate the presence of a molten core, similar to Earth's geodynamo. The planet's surface might be rocky, with potential for diverse geological features such as mountains, valleys, and even volcanism. Volcanic activity could be a key factor in maintaining an atmosphere, replenishing it with gases over geological timescales. Alternatively, Proxima b might be a water world, with vast oceans covering its surface, shielding potential life from harmful radiation. Life on Proxima b, if it exists, would likely look very different from life on Earth. The dim light of Proxima Centauri means that photosynthesis, if it occurs, would rely on infrared wavelengths instead of visible light. Plants or organisms might appear dark or black to absorb as much energy as possible from the faint starlight. Microbial life, the simplest and most robust form of life, might thrive in subsurface environments shielded from radiation. These microbes could rely on chemical energy from geothermal activity, similar to extremophiles found near Earth's hydrothermal vents. If Proxima b has a thick atmosphere, it might serve as a buffer, protecting the surface from stellar flares and ultraviolet radiation. Alternatively, life might develop adaptive mechanisms to survive intense radiation, potentially incorporating unique biochemical structures. The possibility of exotic life forms, capable of thriving in environments we consider extreme, challenges our understanding of biology. This opens up exciting possibilities